Greetings, students. This is the third set of notes in the Plate Tectonics unit. The title is ES 7.3, Subduction, Hotspots, and Volcanoes. As always, you should be writing down everything that is in orange text, and pause the video if you need more time. Here's a picture of a volcanic eruption. Crust types. There are two types of crust, oceanic crust and continental crust. Oceanic crust is newer crust, thinner crust, and denser crust than the continental crust, while the continental crust is older crust, thicker crust, and less dense crust. As far as the age of the crust, new crust is formed uh, at the bottom of the ocean at mid-ocean ridges, so the crust that's under the ocean is closest to those mid-ocean ridges and therefore newer. As far as the thickness and the density, I think of it as the mass of the ocean is just pushing down on the oceanic crust to make it thinner. It's the same amount of material, just in a thinner package. Oceanic crust is kind of like a peanut butter and jelly sandwich at the bottom of your backpack, covered in books and just totally smushed. The Mid-Atlantic Ridge is the area where new seafloor is created. That's oceanic crust, and it's spreading outward from that location. The Mid-Atlantic Ridge is an area of seafloor spreading. Magma is rising to the surface, creating new ocean floor. Closer to the ridge, the oceanic crust is newer. Further from the ridge, the oceanic crust gets older. The Mid-Atlantic Ridge happens to run right through the island of Iceland, which is a very geologically active island. Lots of volcanoes. When tectonic plates collide, the plate boundaries, the type of plate boundaries impacts the type of boundary that you have. You can have continental crust colliding with continental crust, oceanic crust colliding with continental crust, and that's when you get something called a subduction zone. So with a continental-continental collision, that's the thicker crust colliding with thicker crust, you most often results in mountain building. And you can see from the image that the two continental plates just kind of smush upwards. Here's an image of what that looks like. When it's an oceanic continental collision, the oceanic crust is denser, so it tends to sink beneath the continental crust. A subduction zone is a convergent plate boundary where one plate slides beneath another plate. Subduction zones result in volcanic mountains, island arcs, earthquakes, the destruction of lithosphere, and ocean trenches. Oh yeah, and if you have an oceanic crust colliding with oceanic crust, you can also end up with a subduction zone. One section of crust would be slightly denser than the other one, so it would sink beneath. But a subduction zone is basically one section of Earth's crust at a convergent plate boundary sliding beneath another tectonic plate. Mariana Trench is the deepest part of the Earth's ocean. It's also an example of a subduction zone. Here's a diagram of a subduction zone. And another diagram of a different subduction zone. Two plates colliding, a convergent plate boundary where one plate slides beneath the other one, and it often results in volcanic islands. Hotspots. A hotspot is an area that is not near a plate boundary, but it has a deep, localized heat source and often has magma rising to the surface. Think of it as a hole in the center of a tectonic plate. Hawaii is a hot spot, and Yellowstone National Park is also a hot spot. And there is still magma rising to the surface at the big island of Hawaii. The biggest island is currently on top of the hotspot. The islands that are further north and west of the big island used to be over the hotspot, but as the tectonic plate moves, the location of the hotspot appears to change. And even further north and west of these islands, there are underground uh, seamounts and volcanoes that used to be on top of the hotspot. So the plate moves, the hotspot stays still. Yellowstone National Park is famous for geysers and hot springs because it's above a hotspot. It's also a super volcano. So every few 100,000 years, going back in Earth's history, Yellowstone has erupted. And some people think it's due for another. In addition to volcanoes, hotspots have other geothermal activity as well, like geysers and hot springs. The tectonic plate is moving over the hotspot. In the case of Hawaii, the volcanic island that is most recently formed is on top of the hotspot, and the older volcanic islands have moved beyond the hotspot in the direction of plate motion. So here's a diagram of that, where you can see the plate is moving over the hotspot, and sometime in the future, the island of Hawaii will be past the hotspot, and there will be a new island that's over the hotspot. What did the Hawaiian say when she burnt her pizza? She should have cooked it at aloha temperature. The Ring of Fire. This is the area surrounding the Pacific Plate. It's known for lots of geologic activity, including earthquakes and volcanoes. Japan is part of the Ring of Fire, and so is California. Indonesia, New Zealand, the west coast of South America, Alaska, all part of the Ring of Fire. A volcano is a vent in Earth's surface, Earth's crust, through which lava, rock debris, and gas escape. Most volcanoes are associated with subduction, rifting, or seafloor spreading. There are three kinds of volcanoes: cinder cone, shield, and composite. An active volcano is one that has erupted recently. A dormant volcano has gone a long period of time with no eruptions. And you can see the diagram here of the three types of volcanoes. So we're going to talk a little bit about a few different interesting geologic locations on the planet. The first one is Tambora. Tambora is a volcano in Indonesia, and the eruption of Tambora in 1815 is considered one of the largest in recorded history. The explosion was heard 2,600 kilometers away. It caused numerous earthquakes and tsunamis and is estimated to have killed about 10,000 people. Iceland. Iceland is a volcanic island that sits right on top of the Mid-Atlantic Ridge. That means that one side of Iceland is part of the Eurasian plate and the other side of Iceland is part of the North American plate. Iceland is one of the most geologically active places on the planet. There are more than 15 active volcanoes on Iceland. Mount St. Helens, a very active volcano in Washington state, is part of the Ring of Fire. The volcano erupted in 1980, killing 57 people and destroying hundreds of homes in the most devastating volcanic eruption in U.S. history. Hawaii. Hawaii is a chain of volcanic islands that sits on top of a hot spot in the middle of the Pacific Plate. The Big Island is still being formed by two active volcanoes. The underwater volcanoes sit to the east of the Big Island, will most likely become the next island in the chain in about 1 million years. So once again, here's a diagram showing Hawaii with the big island is on top of the hotspot, and the plate is moving to the north and west, and the smaller islands used to be on top of the hotspot. And in the future, there will be a different island. The Deccan Traps. The Deccan Traps are a 1.5 million kilometer area of igneous rock in India that formed about 66 million years ago. One hypothesis states that the release of gases from this huge eruption contributed to the extinction of the dinosaurs. Yellowstone. Yellowstone National Park sits on top of a supervolcano, which creates some interesting geology like geysers and hot springs. The supervolcano last erupted 640,000 years ago. Prior to that, the most recent eruption, there were eruptions 1.2 million years ago and 2.1 million years ago. Each was hundreds of times larger, and in some cases thousands of times larger than the eruption at Mount St. Helens. So I guess what I said earlier about it erupting every couple 100,000 years was a little, was more like every million years or so. But if it erupted today, this is the prediction of how far the ash would spread. So, wouldn't quite get to us in Virginia. Here is the final slide with all the stuff on it that you should have written down. Of course, you can always either handwrite this or type it up, and I've offered you a fill-in-the-blank version if that's easier for you.